Here are the topics we will discuss in this video: revolved features, the axis of revolution for a revolved feature, linear diameter dimensions, and an example tutorial demonstrating these concepts. Topic number 1, revolved features. To help you understand revolved features in CAD software, I will first explain the turning process in a machine shop, which is commonly performed on a lathe. A lathe consists of a chuck, which holds the workpiece, a cutting tool, and knobs which are used to control the position of the cutting tool. A CNC lathe also includes some electronics for automatically moving the cutting tool based on a predefined program. CNC stands for computer numeric control. Here is a close-up photograph of a lathe showing a 3-jaw chuck which holds the workpiece and forces it to rotate in this direction. This is the cutting tool, which can move into or away from the part in this direction, or back and forth along the length of the part in this direction. Here is an example of a lathe being used to make a wooden chess piece. A 4-jaw chuck is used to hold a square workpiece. As the workpiece spins, the cutting tool is moved to cut material away, resulting in a beautiful finished chess piece like this. It is important to understand that the workpiece rotates about its center axis, and as you can see, it doesn't matter whether the original piece was square or round. This is a photograph of an aluminum chess set that I made for my 11-year-old son for a Christmas present. He is very interested in the game and is quite good and has played in several tournaments at school. It took many hours of work to design each piece, program, and machine them using a CNC lathe. It was my way of giving my son something special for Christmas. The gift also included the wooden chess table you see in the photograph, which was made by his great-grandfather and is a family heirloom. Before discussing how these were designed in a CAD system, I will highlight a few of the pieces. Here is the Queen, which was my favorite piece to design. She turned out absolutely beautiful. Here's the Bishop, which looks very traditional, the Knight, and a Pawn. The base of each piece is identical, giving the entire set a consistent look. Each piece also has a sharp ridge around the neck, giving the set a consistent look and portraying a prideful, turned-up collar that you might expect from aristocracy. I decided to design the Knight in the shape of a knight's helmet rather than the shape of a knight's horse, which allowed me to make the piece on a CNC lathe. The flats on each side were made using a milling machine and set the Knight apart from all other pieces in the set. Each piece was modeled in a CAD system, which helped me write the CNC programs for the lathe. Here is the program that was used to machine the Pawn, in case you are interested in seeing what a CNC program looks like. Let me show you how these chess pieces were designed in SolidWorks. First, I needed to create a sketch. Notice sketch 1 is on the front plane of the part. I'll go ahead and edit the sketch so that you can see the dimensions that were used to define this sketch. It's a fully defined sketch, and notice in particularly that I've only sketched 1/2 of the profile of the chess piece. When I finish the sketch, I can choose to create a revolved feature, and I can select the sketch. And notice it revolves 1/2 the profile. 360 degrees is defined here to create a solid part. I could certainly change 360 to 180 to create half of a part. Or I could change it to 90 degrees. I could also change the blind setting to a mid-plane setting. And now it's revolving 90 degrees, 45 either direction of the sketch. In this case, of course, I want to be blind and 360 degrees so it goes all the way around. The Bishop was created in the same way. Notice it's a revolved feature. If I edit that feature, we can see the sketch that defined it. And notice again, I only sketched 1/2 of the profile of the Bishop. The Pawn was created in the same way, using a revolved feature. Let's edit this revolve. And notice the sketch, again, is only 1/2 of the profile of the Pawn. The Knight was created in much the same way. Notice in the feature manager that there are 2 features, a revolve feature as well as a cut extrude feature. Let's roll this back in time to where only the revolve feature existed. And let's edit this feature so that we can see the sketch that defines it. Notice, just like the other pieces, we only sketched 1/2 of the profile and revolved it for 360 degrees. Next, we created a cut extrude, which created the flats on either side. Let's edit this cut extrude so that you can see the sketches that define them. Notice I just created two rectangle sketches and did an extruded cut in both directions through all. Notice direction 1 I chose through all, and direction 2 I chose through all as well, so that it's going through the entire part in either direction. Here's another example of a revolve feature. I've already discussed the revolved boss base, which takes a two-dimensional sketch, revolves it around a center axis, and creates new material. A revolved cut takes a two-dimensional sketch, revolves it around a center axis, and cuts material away. Notice revolved cut 1 is listed in the feature manager. Let's go ahead and roll this back to show boss extrude number 1, which is basically a sketch of a square that's been extruded. I then created a datum plane, plane number 1, so I could create a sketch for this cut revolve. Let's edit this so you can see the sketch. Notice the sketch that was created that was revolved 360 degrees around the center axis. If I rotate this, you can see that even though the revolve was not cutting material the entire time, it doesn't really matter. Wherever the revolve passes through material, it cuts it away. Next, I'll use this bolt to demonstrate another type of revolved feature. Notice the head of the bolt. It doesn't quite look realistic. Here's a photograph of a real bolt, and notice on the head how there's a bevel that goes around the head that seems to be more pronounced at the corners of the hex, tapering off to about nothing at the flat of the hex. I'm going to create something just like that using a revolved cut for my bolt. I'll create a sketch on the front plane, and I like to reorient so that I'm looking at that plane straight on. I'll go ahead and draw a few lines. Start by drawing from here to here, down to here, and back up here. Let's put some dimensions here. Let's make this 1.5 millimeters, and we'll dimension from here to here, and we need that to be 1/2 of the width across the flats of the hex. The width across the flats of the hex is 36, so I'll go 36 divided by 2. Now I also need an axis to revolve this about, so while I'm in this sketch I'll create a center line, and I'll draw it from this center just out here to a certain distance. Now I'll finish this sketch, and I'm going to do a revolved cut. Now notice what's happening. It's taking that sketch, revolving it about the axis, which means it's going to cut a little bit deeper on the corners of the hex. And that makes my bolt head look a little more realistic. Topic number 2, axis of revolution. I will use this part to demonstrate what is meant by the axis of revolution. The top loop of this part was created using a revolve feature. It's listed here as revolve number 1 in the feature manager. I'll click on this and edit the feature so we can see the sketch that defined it. Notice the sketch, and notice also that it was revolved only by 180 degrees. I'm going to edit this sketch so that we can make a few changes. You'll notice here, if I move this dimension out of the way, that there was a center line that was drawn here. That is the line that represents the axis of revolution. It's going to take this sketch here and revolve it about this axis of revolution. I'm going to create a few other center lines. I'll draw another one in this direction. I can also draw another axis right over here. And let's even draw another one here. I'm going to use each of these lines that I've drawn as the axis of revolution so that you can see what that actually means. We'll finish this sketch, and now we'll go into this revolve and edit that feature. Notice here at the first it shows that line number 4 is the axis of revolution. If I right click and clear that selection, I can choose something else. Let's choose this instead. Notice it's now revolving the sketch about this as the axis. I could right click and delete that selection and choose this instead. Notice it's now revolving it about this axis. Let's delete that one and choose this instead. Notice it's now revolving it about this axis. And of course I can reverse that so it goes up and over. This button here reverses the revolve. One goes clockwise, one goes counterclockwise. So hopefully this helps you understand what is meant by the axis of revolution. I'll clear that selection and choose this one. That's really the one I want. And I want it to go counterclockwise. Topic number 3, linear diameter dimensions. I will use this part to demonstrate what is meant by a linear diameter dimension. Let's edit the sketch that defines this revolve feature. And I like to reorient the sketch so that I'm looking at the sketch plane straight on. Notice this 40 millimeter dimension. It's a radial dimension that measures from the axis of the revolved feature to the sketch that's being revolved. Suppose I want to control the diameter of the revolve as opposed to the radius of the revolve. I can certainly do that. Let's go ahead and delete this dimension, and I'll create another smart dimension from this arc to this center line. Notice it's giving me the radial dimension of 40 millimeters. But notice what happens when I drag my mouse to the other side of the center line. Now it's giving me the diametral dimension. Notice this is measuring to an object that's not even there. It's simply using this center line to create the diametral dimension. It knows the radius, so it just doubles that for a diameter. Now I can directly control the diameter. I can even measure to the outside of the arc by clicking on the dimension, going to liters, and measuring to the maximum condition of the arc. I can finish this sketch, and let's edit this feature. And notice it is controlling from the maximum of the arc, 96 millimeters, to the maximum of the arc once it becomes revolved. Topic number 4. Now let's complete an example tutorial that will give you some practical experience with the topics we've discussed in this video. We will model this part using IPS units and 3 decimal places of precision. The material is 6061 aluminum alloy. We will make sure to capture design intent because the quiz will provide numerical values for dimensions A, B, C, and D, and we will need to make sure the part grows or shrinks correctly. The quiz will ask for the mass and location of the center of mass to test and see if you modeled the part correctly. You will notice that the part is described using a typical ANSI drawing containing an orthographic view as well as a section view. This is intended to give you more practice with the skills you developed back in Unit 1. It is important to become good at looking at two-dimensional views of an object and being able to envision the three-dimensional part in your mind. Can you envision this part? Here is what it looks like. In the future, I won't be providing a three-dimensional view like this. So if you are having a hard time envisioning a three-dimensional object from two-dimensional views, you will probably want to go back and review Unit number 1. In SOLIDWORKS, I'll choose New and select the part template. And I'll come to Options. Under Document Properties, I'll change the units, the IPS system indicating 3 decimals precision here and 3 decimal precision here. And then I will change the material, don't forget to change the material, to aluminum alloy 6061. Now I'm ready to create a sketch. I'll sketch on the right plane, and I'm going to begin the sketch by creating a center line from the origin. This will be my axis for the revolve feature. And I'll create some solid lines, and I'll just roughly sketch the profile that I want to revolve. Now that I have the profile sketched, I can start placing some geometric relations. I'll right-click here, select the midpoint, vertically align it with the origin. I'll choose the center of the arc, vertically align it with the origin as well. I'll choose these 2 points and horizontally align them. I'll choose these 2 points and horizontally align them. I'll choose these 2 points, make them horizontally aligned, and these 2 points horizontally aligned as well as these 2 points horizontally aligned. Next, I'll take these 2 lines and make them equal in length. Same with these, we'll make them equal in length, and we'll take these and make them equal in length as well. Take these 2 and make them equal in length. Now we're ready for some dimensions. First of all, let's dimension the angle between these 2 lines. We'll make that 60 degrees. I'm also noticing that I need this line and this line to be parallel to one another. Now let's go ahead and dimension this to be 0.25, which is a 1/4 inch. And we'll also dimension this overall width to be 1 inch. I want the distance from here to the arc. Notice it's giving me the distance to the center of the arc, but that's okay. I can place it, come to liters, select to go to the maximum arc condition, and I want that dimension to be 1/2 of an inch. I want the width between here and here to be 3/8, which is 0.375. And I want this distance from here to this center line. It's giving me a radial dimension, but notice if I drag it below the center line, it gives me a diametral dimension. Let's make that 7 inches for now. And let's create this radius to be 0.125, 1/8 of an inch. I also want this dimension from here to here to be a diametral, so notice I'm coming below the line. I want that to be a 1-inch diameter. And from here down, I want that to be a 1.5-inch diameter. This needs to be 1.5 inches long, and this angle needs to be 60 degrees. Now this is fully defined, so I'm ready to finish the sketch. And I'll come to the Features tab and select a revolved feature. I want it to be 360 degrees, so it looks good. Next I'll create an extrude, and I'll make a sketch on this face. And I like to reorient the sketch, so I'm looking at it straight on. Let's draw a centered rectangle. And I want it to be a perfect square, so I'll make these two lengths equal to one another. And let's dimension this one to be 0.25, 1/4 of an inch. Now let's take this point and the origin and make them vertically aligned with one another. But notice it still doesn't know where it's located vertically, so I'll take this point, hold down Control, and choose the edge and make them coincident. Now this is fully defined, and I can create an extruded cut. And I'll choose to extrude through all. Now you can see that I've created that key slot in the bore of this pulley. Next I'll create a sketch on this face, and again I'll reorient so that I'm looking at that straight on. Next I'll create a center point arc, and I'll choose the center point and strike the arc. Another center point and strike this arc. Now I'll create two lines from here to here and here to here. I'm noticing that the computer automatically put a perpendicular constraint, which I don't want, so I'll hit that constraint and hit delete. And then I'll create some fillet radii in each of these corners. And those radii need to be 0.25 inches. Now I'll take this arc and this edge, they need to be co-radial. And I'm going to take an angle dimension between this line and this line. That needs to be, let's make it 100 degrees for now. And let's create a dimension here. This radius, let's make it 2.5 inches. Now notice this line isn't necessarily pointing straight through the origin, and it needs to. So I'll select this line and the origin and make them coincident. I'll do the same with this one. This line and the origin, make it coincident. Now it's pointing directly through the origin. But we are also noticing that it's not centered. So I can right-click on this arc and choose its midpoint, as well as the origin, and vertically align them. Now this sketch is fully defined, so I can finish the sketch. And let's create an extruded cut, and we'll select through all. Now the part is finished, so I can go to the Evaluate tab under Mass Properties. And we can see that the mass of this part is 1.633 pounds, and the center of mass, the y-coordinate, is located at 0.165 inches. Yours, of course, will be different because you'll have different dimensions.